Okay, here we go for our lab. Hey, you're going to make a JC matrix and we're going to template the weight. Alright, I'm not trying to be tricky, just assume it's an integer and you'll be fine. Weighted directed graph via an adjacency matrix. So I expect you to use an adjacency matrix for this one. Vertices are given an index starting at 0 and ascending, class W. We will not weight the vertices. So there are situations where when you get to something, there's an additional weight. We're just weighting the edges. I think that's the simplest way to go about it right now. You don't have to have this if you don't want to, but I give it to you in case. Initialize it with the number of vertices, deconstruct. All right, oh wow. For add vertices, okay, let's go to this one first. Adds amount vertices to graph, returns the starting point of the vertex count. Returns the starting point of the vertex count. So if I have 100 vertices and I add 10, you're going to have 110 and you return 100. Or you return 99 technically. All right? You're going to have to increase the size of your adjacency matrix for this one. The hard one is removing a vertex. Oh boy. This one's actually really hard. It's probably the hardest part. So if we're removing 4, what do we need to, oh, well, that was the worst one to remove. If we're removing 4, doing it anyways.
Ouch. So we would go through all of 4's connections and every other node that's.
So you have to, first delete all the other connections. Good call. You do that first. Then the next thing that's problematic is 5 is going to become 4. So you got to shift these zeros over, and apparently that's 6. And then you also, everything after this value, you've got to also shift. So what happens is you shift all this over by 1, because 5 going to, was that 6? Yeah, 5 going to 6 is now going to be 4 going to 5. So you got to shift all these down by 1. Kind of annoying. And then you can delete this row. Or just shift it all down. Either way works. You got that?
What you're saying is we should use a linked list of linked lists instead of an array?
No, don't do that. No. I'm trying to show you why this is annoying to do. By making you do it. Yeah, I know. Yeah. All right, well that was interesting. I started with the hardest thing. All right, adding an edge. All right, you think you can add an edge? This is, okay, this is the give me. Hopefully. We're removing an edge. I'm not being tricky. Just shove something in there. Depth first search, which we did today in class. Ooh, breadth first. You may have to go look up how to do breadth first. Although since I did depth first today, that means on Monday, I'll do breadth first with the other representation of a graph. Return the weight if they're adjacent. Not trying to be tricky. And then here I want you to run Dijkstra's shortest path algorithm from start to end. Simply return the weight. I just want the weight, the total weight. Return -1 if it doesn't exist. Again, I give you a print function in case you wanted. It's not necessary to get 100 on this lab. I think this is after Thanksgiving. Yes, because otherwise it would be the Wednesday. But yeah, that's just wrong. So it's Monday after Thanksgiving. Please do get started on it. Don't wait. You're gonna be sad. Yeah, any questions, comments? Nothing?
Size.
What's that?
Size.
Size. Yeah, this data structure is a little more complicated, but it's more of what it's representing because it's just a 2D array, guys. Right? That's all it is. That's it. All right. That's all for today. Have a good weekend. I will see you on Monday, hopefully.